Hey Mzansi coders, what's going on guys? I hope you guys have been great. So today we're actually going to be looking at balanced binary tree, right? So they say that given a binary tree, determine if it is height balanced, right? For this problem, a height balanced binary tree is defined as follows. A binary tree in which the left and right subtrees of every node differ in height by not more than one, right? So let's hop to the whiteboard and see what I mean by that. So like I said, all the time, try to write the question in terms like the way you understand it, right? So what they mean essentially is that assume that you're given a binary search tree, right? Like we can say 9, we can say 7, we can say 8, we can say 6. Then here we can say let's probably say 10. It's fine. So what they mean is that all the node in the left subtree, you need to get their height. So their height in this case is going to be 2, right? And the height in the right subtree is going to be 1. So as like they said that the difference in terms of the height shouldn't be greater than 1, right? Should be equals to or less than 1. So what you want to do in this case, you want to take the absolute difference. So you're going to take 2 minus 1, right? So this is going to give you 1. So this is this balanced tree that we're looking at here. It is balanced, like we do accept this, right? So let's look at the case whereby this might not be balanced. Okay, so let's say we had 9. I'm just going to repeat the same thing. 7, and we had 6 and had 3, right? So here it was 8. Here, let's say we had also 8, something like that. Okay, cool. Then here we had 10. This is just an example, guys, just for me to show you what I mean. So if you look at the left subtree, if you get the height, it's going to be 3. And if you go to the left, to the right subtree, and you get the height, it's going to be 1. So whenever you take the absolute difference of these two heights, it's gonna say 3 minus 1, then you're gonna be 2. So this is not a balanced binary search tree because we know that the height is greater, so it does not fit the rules that we've been told when we read the question. Okay, so we can't accept this, right? So however, like I always say, it is quite important for you to kind of like understand that we're not only looking at the root, right? You also have to look at these nodes, like also like check if like the left subtree of this node here, it is greater or less than, like you're still validating if it should be less than or greater than 1. Okay, so you also have to do it at the node level, not only at the root. Okay guys, so that's what they mean about the question. I hope I was able to clarify it. Okay guys, now what we want to do is that we want to actually write the solution in our own ways, right? Like, because now we understand the problem, how about we write the solution in our own ways, right? So when we're writing our solution in our own ways, let's write it in such a way that we're structuring our code, right? So this way it helps us that when we're shifting from the whiteboard to actually writing the code on LeedCode, it's much easier. So the first thing that I'm going to do is to create this simple binary search tree so that we can like have something that we can look at whenever we're writing the logic now. So just gonna say that something simple, nothing complex. Cool. Then what we want to do at this case is that I'm thinking of actually starting from the bottom and we work our way through to the top. The reason is because we can now get the height of each node, and we can get if it's balanced. Then we can push that information to the node at the top. Then we can push that information to the root, just like that, right? So that's why I'm saying let's work our way through. Then when we get to the root will know what's the status of each node in the left subtree or the right subtree. Then it can make the final decision, right? It will know all the information. It will know the height. It will know if it's balanced. Remember that I said you need to check at each node if the height and if it's balanced, right? So that's why I'm saying working our way from the bottom to the top, it's going to be much easier. Okay, so how can we do that then? We know that we have to do this recursively. So, but when we get to the base, like what will then happen is that we're going to get, this will return null. It will return nothing. So, but what should we return from code perspective, right? So I think we should return true or balance, right? Or zero as signifying the height. Why am I saying that? Because you can imagine that this is only the root that you had, or this is only the node. So what will happen is that this does not have height, right? Does not have anything. So this should be zero. Okay, so this also, it's balanced because we know that it does not have the left subtree, it does not have the right subtree, so it is balanced, right? So meaning that it is true. So why am I telling you this? It's because this is what we actually have to return here. So we're just going to have to return true and zero. So true signify that it's balanced, and zero signify the height is zero. Okay, then this is what actually we have to write from the code, right? Like I said, whenever we say something, let's also like say it in such a way that whenever we go into shift towards the code, it's easy. So we can say if root, right, is none, right, please return to us true, right, and zero. Okay, so now the method that I'm thinking of using, we're gonna use let's use the post order, right? So why am I saying this? Because we want to start at the left, then we say right, then we go to the center. So I think in this case, the post order approach will be better. So we're going to start to the left subtree. Sorry about that. Then we're going to go to the right subtree. Then we're going to go to the center. So here, it'll also do the same. Right subtree will return true, zero, right? Now, these results have to bubble up, have to go to the top. What will then happen in this case, right? Let's write a logic. So when we're going up, we need to understand the balance status. At the same time, we need to take into consideration the rule that we have been told that for it to be balanced, we have to make sure that it's actually less than the difference of height. It shouldn't be greater than 1, right? So we have to say for us to get the balance, we're gonna say if balance, because we know it's gonna write, so return true, because we got true, you still remember. So we're gonna, maybe we define this as balance left, and we're gonna say balance right, because we got true, you still remember. So we got balance right. So, but there's a new logic, like I told you. It's not only these two, but we also have to check the height. You still remember the rule. So have to say and, then we need to check the height left, right, and the height right. So we need to check if these are the difference between these two, it's less than or equals to 1. So we're gonna take the absolute difference. So you're gonna say height left, right, minus height right. Then we're gonna ask the question, is that equals to or less than 1, right? So that's how we're gonna do it, right? Then we're gonna get an answer here. We can call this as balanced. Say equals to. Okay. Hope guys I'm making sense. Sorry if like my handwriting is bad, maybe it might be confusing, but like that's how we're gonna go with it, right? So we know that we're returning two things. We're returning balance. Now we have covered this balance, which is cool, but we haven't covered the height because it has to increment, right? Like now it is going to be, it was 0, then when you go up, it has to be 1. You know, it represents this level, it has to be 1, it has to be 2. How can we do this, right? So we can do this by actually saying, how about we say 1 plus, we're going to take the max, right? The max of height left, right? The max of height left and the max of height right, right? So it's like you can imagine that we're saying max 0, right? It's like you can imagine we're saying max 0, this is left, this is right, then we're just saying +1. So this is going to bubble up 1. So here, the first code here, it will return true and it will return 1. Then it will give it to the subsequent node, just like that. Okay, guys? So I think that's it. Like I think we kind of like explain everything that we need to do, and let's go and try it out with code and see if we can actually be able to solve this. Okay, guys, now let's solve this solution, right? So the first thing that you can realize is that we can see that the output here, they only want true, right? And when we were working on the whiteboard, we saw that actually we have two output, which is the height and the tree, and whether it's balanced, right? So how about then we create our own function. So DFS, so it's just gonna take the root, right? Then we're gonna say if root is none, then we return true to signify that it's balanced, and we return the height. Okay, so the second thing that we want to do is that we want to traverse to the left subtree and we want to traverse to the right subtree, right? And when we're doing that, we know that all the time we want to return balanced and height all the time, right? So we're gonna say balanced left, right? And we're gonna say balance left and height left. Okay, guys, so we're just gonna recursively go there because we know that we're always gonna return true and 0, right? So we're gonna say take the root of left, right? Just gonna copy and paste so that we save time. So I'm just gonna paste this, and we're gonna say balance right, right, and height right, and we're gonna traverse to the right subtree. Okay, then when we're done, now we have all of these things, right? So like we said, what we want to do is that we want to get the balanced, right? We're gonna call this balanced. So it's literally gonna take the balance left, right, which will return a boolean all the time, and it will check the balance right because it has to check the status of each node. So it's gonna be balance right. So remember, like I said, this is gonna return true, this is gonna return true, and as we move on, not all the time it will return true, sometimes it's gonna return false. Okay, then now we're not only checking these two, but we also have to check the height. So we're gonna say and check the absolute difference of height left. Say height left, then we're gonna take subtract this, the difference, and so you're gonna write right, then we're gonna say equals to less than equals to 1. Okay, okay, perfect. Then we're gonna get the height because all the time we have to return two things, right? So now we have to get the height. So the height is gonna be like I said, just have to say 1 plus max, then we just give it the height left and height right. Okay, I'm just gonna copy this, then I'm just gonna give it the height right. Perfect. Then we just return the balanced and we return the height. Okay, guys, hope this makes sense. We explained this in the whiteboard. I hope you guys actually understand what's going on. Like, but I said in the whiteboard, like, this is how we're going to go with it, right? So we can see that actually we have to return true only. So what we can do then is to actually declare a variable to say we can have balanced, right? Balanced, and we can have height, right? Because we know we're returning two things. Our function returns two things. So you can say DFS, which is going to take the root, then we just have to return balance because they only want true only. Okay, so let me just check balance. I hope I did not make any mistake, but I think this should work, guys. So let me submit and check. Perfect, guys. So this was accepted, and we're able to kind of like solve the problem. I hope you guys actually understood everything. If you didn't, just leave a comment below and I'll explain or write a blog about this. Thanks, guys. Bye.